See this problem. A closely wound solenoid of 800 turns and area of cross section 2.5 into 10 to the power of minus 4 meters square carries a current of 3 amperes. Explain the sense in which the solenoid acts like a bar magnet. What is its associated magnetic moment? Our motive is we have a solenoid like this and it has some N turns and the current is flowing through this solenoid and the area of cross section of this solenoid A is given. We need to find out the associated magnetic moment of this solenoid which is working as a magnet and the sense in which the solenoid acts like a bar magnet. Like we need to specify the poles. That is our motive. Now come to the investigation part. The number of turns N is equal to 800 turns and the current I flowing through this solenoid is 3 amperes and the area of cross section of this solenoid A is equal to 2.5 into 10 to the power of minus 4 meters square. We need to find out the magnetic moment. Now come to the resolving part. The magnetic moment of the solenoid M is equal to NIA. This is the direct formula given in the textbook. That is equal to 800 into 3.0 into 2.5 into 10 to the power of minus 4, which gives a, so if we simplify this value you will get 0.60 joule per Tesla. This is the magnetic moment of the solenoid. Now we will sense this solenoid as a magnet. Like we need to specify the magnetic poles. For example, if the beginning of the loop contains the current in clockwise direction, then the end in which the current is entering will be act like a south pole. Look at this. This is the clockwise direction of the current and entering into the solenoid. So that end where the current enters into the solenoid, that end will behave as a south pole. And if it is anti-clockwise direction, if it is entering into the solenoid in an anti-clockwise direction, then the pole of the solenoid at the current entering side will behave as a north pole. You can see the notations what I am specifying here. So here it is clockwise, so S is also seems to be clockwise. Here it is anti-clockwise and N is also specifying like anti-clockwise direction. So by knowing the direction of entering of the current through the solenoid, we can specify the poles of this solenoid so that we can sense the magnet and its magnetism.